So you know me, at least you sort of know me. So again, I'm Vijit Pandey, and today I'll be covering Module 2. So we divided the course into 10 modules, as you know. And today we'll be doing Module 2, or at least starting on Module 2. So I like to keep students oriented as to where we stand and what we're doing. So here's the 10 modules that we're doing in this class. And then today we're going to start Module 2, which is identifying stakeholders and their preferences, and then talking about the house of quality, which is a tool that we use to encode customer preferences, customer needs into a system design process, okay? System or product design process. So I hope you all remember that we are taking a product development perspective to systems engineering. So if we go through the entire step of developing a product or a system, then we understand systems engineering better than we would any other way, okay? So that's just my perspective. All right, so let's get started today. So this is the overview of my lecture today. So first is the topic that I touched upon in the last class, which is why are systems built? Why does anybody decide to build something? Who are the stakeholders? And then acquiring preferences, house of quality, and then we'll do a vegetable peeler example. Now this has been used quite a bit in systems engineering and product development classes, so I apologize for not being original, but I find this example very, very enlightening. And then we'll work on it together here, right? And then you'll see that we've done it many times in our classes that I teach over at Oakland, and then we see that we pretty much end up with the same set of customer needs. And then if we have time, we will do a more involved example, which is a chemical scrubber example, which is actually a system, so to speak. And then we'll briefly talk about functional diagrams. And then we'll talk about thinking about product demand. So you will see that there's many concepts in systems engineering that overlap with each other. Okay, so when you talk about preferences, you could be thinking decision analysis route, or you could be thinking preferences as in what do I want out of a product so that I can build, or what a customer wants out of a product so that I can build it so that it best satisfies their needs. Okay, so there's a few perspectives, so I'll try to touch upon both the perspectives in this class. Okay, so let's get started. And as before, if you don't interact, this will be a very short class. Okay, so I encourage you to ask questions and interact. And maybe you can lower the volume a little bit because I'm getting feedback. Yeah. Okay, great. So why are systems built? Anybody remember why are systems built? Right, meet the needs of customers and stakeholders, right? So there's only basically two major bifurcations you can say. I mean, if you talk about why does somebody build something? Because we were told, let's say it's a one-off product, right? So the company that I worked in, we worked on a complex system design project where they said, hey, can you build this? And we said, yes. So it was a firm order to us. It was like, so we had already established ourselves. And it was a very short stint for me for that company, but that's okay. The other is like, we design something anticipating that customers will buy it, right? So there's no set demand in place, but we do some sort of needs assessment, some sort of demand modeling, any sort of analysis that you would do so that you can actually say that if I make this system and market it, enough people will buy it so I can make some money, okay? And I'll reiterate probably more times than you would like me to reiterate that there's nothing wrong with a manufacturer wanting to make money, okay? Anybody that makes money is a viable enterprise, gives people jobs. You wouldn't want companies that don't make any money. And then money also gives you a very good metric. In fact, some people would say that the overarching goal of all systems engineering practice should be to maximize profit for the manufacturer. That's something they would say. I don't know if I say that necessarily, but I definitely see value in that perspective. Okay, so like I said, there's two major ways you can think about why somebody built something: because they were told, they had a one-off order, or an assessed need through demand modeling or some other process, okay? And I also have highlighted a few times that I will refer to the end user as a customer. So even though customer has a connotation that somebody who goes to the market and buys something, customer is the end user in this case, okay? So just let me use that phrase. Okay, so the other questions we can say while we're thinking about this to just get a little bit deeper into why are systems built and how they're built is that how do I know the voice of the customer? What does the customer want? That's not as easy as you might think. And then will any product suffice? Okay, so that's also not very as easy as you might think, right? You might say, I think the customers want this, which is already a difficult problem. And then you say, they want this, I'm going to make this that satisfies that need. It's not that easy either, right? So that product or the system also has to have some measure of optimality. Okay, so if you have a product A and product B, and product A is better and it's also cheaper, good luck selling product B. You're not going to sell anything, okay, because A is better and cheaper. So you have to think about some sort of optimality that it has to have multi-attribute optimality over multiple attributes. And then multi-attribute nature of this this whole endeavor of systems engineering, if you go back to the, we're talking about the axioms of systems engineering, what makes me think that they're systems engineering problems. Interdisciplinarity and multi-attribute nature is key, okay? So now we got this straightened out. Let's go to our next topic. Who are the stakeholders? So this is a pretty easy one, okay? So I mean, you could go nuts doing this. The way we think about it in systems engineering, or at least academically, is that there's three major players, right? Manufacturer, the entity that decides to manufacture something. It could be a one-off product. It could be something that you assess the need for. For example, it could be a government contractor. It could be a company that makes like toothpaste, all those manufacturers. And then you have customers, which are the people who would use that product, right? So in a classical sense, they will buy that product. They could also be just the people who use that product, because we're using customer as a more general construct than just somebody that you think of a customer as a daily basis. And then we have legislators, right? So we really cannot do anything, at least in this day and age, without government intervention, okay? People in aerospace will tell us that there's so many rules and regulations that we have to follow so that it almost becomes a stakeholder. And that's a stakeholder for a good reason. If we say that manufacturers can maximize profit, right, then how do we know that they're using scrupulous means? How do we know that their products are safe for customers to use? How do they know that, I mean, if you're, again, sorry to give you an example many times, but then if airplanes are not safe, we have a problem, right? And if we left it to manufacturers, we cannot guarantee that they will follow the best practices. So we need government to enforce certain laws to make sure products are safe, make sure that there's no monopolies developing, there's no anti-competitive behavior, and so on and so forth. Right? So there's usually three stakeholders that we can think of in a system development process. And your perspective could be different in different cases. So some products that, if you're far away from the boundary of illegal or allowed versus not allowed, then you can just focus on the customers, right? If you're making something like, let's say, a chair, yeah, they have to be ergonomic, they have to be safe, and there's some regulations on that, but you can pretty much have a lot of freedom. But if you're making pharmaceuticals, oh yeah, legislation is big, and government is a big player in that domain. Okay, so these are the three stakeholders. They interact with each other, and then you have to consider them. So again, some researchers would say that you can come up with an overarching mathematical model of a system development enterprise, or sort of exercise, where you would have all these stakeholders' preferences taken into account. Is that possible? I don't know, but it's a good thing to aim for. But it's okay to have, like, narrow focus. Sometimes you just focus on some of these interactions. Yes?
So we have ignored the middlemen, so like retailer, customer, wholesaler. Only manufacturers and customers are included, so retailers, wholesalers.
Right. I mean, so you can add, what you're talking about is adding resolution to these things, right? So we can add resolution to these things all day long, right? So we can say, even with let's say government, we can talk about the executive, the legislature, the judiciary, the police. I mean, we can keep adding layers to it. So a higher level understanding is good enough, right? So retailer just makes sure that the customer gets the product. In fact, more and more, you will see that with online e-commerce, we're seeing that customers are able to sell, manufacturers are able to sell their products directly to the customers, right? So a lot of this movement is already happening. So yes, I mean, in the grand scheme of things, you would consider everything, but I call it the map paradox, right? Or when you have the map of the Earth, and you would say, okay, well, why can't we add more details to this map? Because I can't see certain things. Then you say, okay, well, let's add more details. And say, oh, I can't see this street, I can't see this building. Then I keep adding more details. In the end, if the map of the Earth has as much detail as the Earth, guess what? It is as big as the Earth and practically useless, right? So it's a very difficult but worthwhile exercise. We call it meta problems. Like, how do you confine the boundaries of what you're thinking about, right? So if for example, you are thinking about the supply chain optimization, which is a system, then you would think about suppliers and then how much what is the delay and what is the backlog, what is the bottlenecks and things like that, what is the profit margin of each step in that. So what you're saying is absolutely correct, okay? If we choose to be at that level of,
what is the system of interest?
Exactly. Yeah, what is the universe of interest, or universe of discourse, however you want to say it, okay? It's a good point though. Okay, so we'll get to acquiring preferences. Okay, so first and foremost, we distinguish between two kinds of preferences, which people will call stated and revealed preferences. Has anybody heard of these two terms? Huh?
Yes.
Okay, what are they? What do they mean?
So, stated preferences, it means like, for example, if a customer wants to purchase a car, like a car, like a specific, like customers will be having like, they will have a specific need. Like some customers will need a model with a back wiper, or like any that delights the customer, which only the specific high-end models will have. And revealed preferences, as in it should be there in the model, like a basic necessity. For example, a good mileage.
Okay. So I think we're getting slightly off track. Does anybody have any other comments, or do you agree with what was being said?
Stated means like in mobile phone, the calling feature is necessary.
Okay, so you're making the necessary good to have and must have features, right?
Yes.
That's not what we're talking about here. Okay, so good to have and must have features are like, what is the basic necessity out of a product or a system, and what is would be good to have that distinguishes your product, makes it luxury, whatever, and so on and so forth. This is different. Okay, this is exactly what it means literally. This is stated versus revealed. Means that I tell you I want something, I state it, versus you observe me do something, so revealed from my actions, okay? And that's something we spend too much time talking about. But before we do that, I like to say that your assessed preferences should be correct and scalable. Nobody would disagree that when you assess people's preferences, hey, will this customer pay this much more for this much improved, let's say, luxury feel and this much improved miles per gallon, right? Obviously, those deductions that I make should be correct, right? If I ask questions to the customer and I don't care if I get the right answers, then what is the point of doing anything? So truly reflect the customer's decision-making behavior. Nobody can disagree with that. And it should be scalable. That's something we sometimes don't think about. Scalable means that I should not just figure out, hey, that person wants a yellow car, and then come back and tell my boss, hey, people want yellow cars, let's make yellow cars. Now, maybe you have to think about scalability as in, like, are they thinking of different color options, right? So if you are able to generalize, same thing with price. You say people are willing to pay a little bit more for a little bit better features. Well, how can I scale it? Can I say, can they pay 3 times more, 5 times more, 10 times more? Can I scale this as opposed to just getting the answer to the question I wanted to ask? Can I actually generalize it a little bit? Of course, we can't scale it to any number. We can't say that, I don't know, a $20,000 car. We can't say, oh, what about $2 million car? No, but if we have preferences around 20,000, we should be able to reasonably say, you know what, if we increase this by 2,000 and decrease that by this, our model still is accurate, okay, and it still gets us something. So scalable and correct. Those are the two things that I would say about preferences. Before I get to stated and revealed preferences, so stated preferences are through surveys and focus groups what people state. I said that I want it. And then an alternate way to acquire preferences would be to observe customers' decision-making behavior and infer their preferences. Okay, so in my during my PhD research, I did quite a bit of work with environmentally benign products. Okay, people be good for the environment, products that would be good for the environment. If you ask people, hey, will you pay more for a product that is biodegradable? Most likely people will say yes. You can hear me still, right? Yeah. Okay. Yeah, I love the environment. I'll pay more. But when you watch them buy the product, they want to buy the cheapest. So there's a distinction between what people say and what they do, and that's exactly what this is, right? And this is a completely different approach to getting people's preferences. If I want to get your stated preferences, I'll ask you questions. If I want to watch your revealed preferences, I'll observe your behavior. I'll look at sales data from a dealership. I'll go to the store and ask them what of what you're selling and how much of it you're selling, right? And actually some way more intrusive methods that we have now because of the great internet. Okay, so let's get to the next slide. So here's I have a 2x2. I'm sure you've heard of 2x2s, right? So basically, if you have two attributes or two decision-making parameters, you take high-low of this and high-low of that, and then suddenly you make a point very convincingly. Okay. Of course, there's simplifications when you do this. Again, we're losing resolution, but an easy way to win arguments. Okay. So the rows are stated and revealed preferences, and the columns are advantages and disadvantages, right? So you have stated preferences. I would say relatively easier to acquire. Okay. If I wanted to know what cars you guys would prefer to buy, I can just do a survey right now. But if I wanted to watch what car you buy, I'll have to maybe wait for years and follow all of you around. And that's not very practicable, right? So the advantages of stated preferences is relatively easier to acquire and can be used for products that may or may not exist. I'll get to that later. And then the disadvantages of stated preferences is no guarantee of consistency. I can say whatever. People can say whatever. Has anybody taken surveys on their phone and on the internet and in the restaurants and pamphlet? How many times do you guys speak the truth? Huh? You're not really thinking carefully. You don't care if you get the right answer. Sometimes you say yes, 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 yes. Sometimes you're in a bad mood. You say no, 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 no. And then the manufacturer thinks that 37% of our customers don't like our product. It doesn't mean anything anymore, right? Stated preferences. Another disadvantage is that may not even have formed in your mind. The preference may not have formed in your mind, and that's something that we talk about. If I say, let's say this university decided to buy a quantum computer, right? Would you say that, how much should the university spend? Let's say they asked you. You say, I don't know. I haven't thought about it, right? So asking people who haven't thought about a problem deeply enough questions about it is a bad idea, right? So psychologists will call it priming. If you're about to ask a question, make sure you give them the context. Make sure you let them think about it before you ask them that question. Otherwise, you'll get nonsensical answers, right? So that's that. Revealed preferences reflect the observed true purchasing behavior. If I see what you do, then I know that's what you do, right? If I see that every single time you prefer a cheaper product to an environmentally benign product, I know you want a cheaper product, right? So it's a little bit more accurate representation of what it is that you want. The disadvantages is that, oh man, it's expensive and difficult. I mean, it's getting easier now, but how would you know what cars people? You have to collect data from either dealerships, or you have to get data from manufacturers. You have to observe people's behavior. Of course, Amazon and all these companies, they do a lot of this because people buy stuff online. So we have data that we can buy. They can observe. Other people can buy data from your online. That's why these cookies and all these tracking websites are working on. So it's getting easier now to get your revealed preferences. Okay, you will see that a lot of these online e-commerce websites will suggest things because they have seen what you do, and then you get an email regarding it, and so on and so forth. So difficult to acquire. But revealed preferences cannot be this. So this is where I'm going to connect the thing that I skipped. So top left versus bottom right. For stated preferences, the advantages can be acquired for products that may or may not exist. For revealed preferences, the disadvantages cannot be used if the decision scenarios change significantly or products or systems that do not exist. Okay? So if I say, how many of you would buy a flying car? Okay? I can ask that, no problems. Can I get a reveal? How many of you have a flying car right now? 0? So there's no way I can get revealed preferences, right? There's no way I can watch your behavior, collect data, because it doesn't exist. So that's the negative of revealed. Revealed only is previous purchasing behavior. I can extrapolate. So obviously, before you jump to a conclusion that I prefer revealed preferences, you should think about this. And when you say I prefer stated preferences, you should think about the disadvantages and advantages. Okay? Any questions so far or comments? Simple stuff, right? So some of this we've already touched upon. We acquire preferences through surveys, right? Which is asking questions to people. You can do it in person. I can do a survey right now. You can do it online. I mean, you get the idea, right? Asking people one way or the other questions. Now, if you think this is a trivial task, you have something else coming. This is a very difficult task. To design questions that prime customers and respondents to give the right answer, to give the answer in the form that you desire, is very, very difficult. So many times we've done surveys and then we thought that, this is airtight. There is no issues. We're going to get good answers. And then as soon as I post it, I'm like, we're not going to get any good answers because either the answer is obvious or something like that. I'll give you an example. So I was teaching a augmented and virtual reality class. And then one of the things with, anybody played with augmented virtual reality here? Yes, no? Yeah, okay, one person. So the idea is that if you see a 2D CAD drawing versus if you're immersed in the environment, will you be able to find errors faster? More or less, yes, right? I mean, some things it's trivial. So when you do a survey, you have to create an environment in Unreal Engine or something, and then you have to design the survey. But why are you doing the survey when you already know the answer, right? I'm not saying this will be true every single time in every single scenario, but certain cases you can already know the answer, right? So many times people will spend so much time collecting data on things that they already know or can infer the answer. So like I said, so surveys, in-person, online, whatever, telephone, pamphlets, all that can be done. You already know the negatives of it. And then focus groups is a little bit more targeted, right? So you recruit people, you have them come to either your premises or you go to them, and then you give them some more specific scenarios, right? So if I was making a new, let's say, electric lawnmower, I would say, you know what? Asking questions is one thing, but showing them what it looks like, they handle it a little bit, and then they have design suggestions. We take a prototype in those focus group meetings. That is very, very useful. Okay, so focus group meetings are obviously more expensive and more logistically challenging to design and get data for, but they give you better quality answers, but they're still stated preferences. They're not revealed preferences. So sometimes you'll get some revealed preferences too, like, when you watch people observe and they say, you know what, I noticed that people were mostly picking it up with their left hand, so maybe it shouldn't be that heavy, or those kinds of things. Okay, and finally, I mean, of course, there's internet-based tools for acquiring preferences. Like I said, already doing surveys on Qualtrics or those places, or an online company collecting data. You all know this. I'm sure they have frequency cards in stores here, right? If you go to a store and if you're frequent, you scan your card and the next time you get a discount or something like that, yes. Right? They're not happy to give you a discount. They're happy to get your data. I don't know if you know this, because now they can track this customer. What did you buy over the last 3 years? And many times they will know before you do that you're out of milk, okay? Because they say, hey, last time this person bought milk was 5 days ago. Of course he's going to come or she's going to come buy milk. So that's revealed preferences, but they're collecting data on your behalf, okay? All right, so, and finally, anybody familiar with, has done an IRB study, Institutional Review Board study? So if you are trying to, and this gets critical, right? If in focus groups, let's say if you're having customers actually interact with the product, or if you're doing surveys or asking questions, very quickly you can cross the boundary of what is safe and what is no longer safe. Okay, and then of course the continuum of safe or unsafe is pretty large. So if you're trying a medicine or trying a tool, they can get injured. Who's responsible? Those kinds of things, right? So you have to first get those studies, especially if you're going to publish it, reviewed by the institutional review board. I'm sure this university also has an institutional review board, which will look at your surveys, which will look at your experimental design and say, you know what, you should change this, or you should have this in your consent form, so on and so forth. Okay, so definitely, I mean, IRB I mean, we've gone through many IRBs. I've done many human subject research projects, all the way from simple survey type questions to a little bit more involved where they're working on simulators and so on and so forth. So, and it's not an easy process to go through, but it's a required process. So look at Belmont report, look at IRBs and why IRBs are so important and why universities require that you have an approved IRB application before you do any human subject research. Okay. So these are various techniques. You already know about these, so I'm not going to spend too much time on how to acquire preferences. Okay, so now changing gears now. This may sound like a non sequitur, but I have to make this distinction now because I'll be using it pretty frequently. We have what we call customer needs, and we have what we call functional requirements. Okay, so many times people conflate the two because they're not careful, but in our discussion, this distinction will be very, very important. Okay, so customer needs refer to an almost verbatim requirement from the product as requested by the customer. So they might say, I want 18-inch wheels on my car. Okay, it's a customer requirement. Actually, that would be pretty close to being functional requirement too. So maybe not that one. But you could say something like, I want my car to be fuel efficient. Okay, and then functional requirement would be how the product addresses it. So here's an example we have, right? So customer needs are essentially an input to the product development process. So in the case of a vacuum cleaner, you would say the product should be able to clean a carpet of accumulated dust particles. I say, here's a carpet. I want something that cleans dust particles out of it. Functional requirement would be, hang on a second, one way we can do this is the product generates enough suction to remove accumulated dust particles from the carpet, as in a vacuum cleaner, right? So customer requirement, customer just says, I want a clean carpet. That's what they're saying essentially. I want dust to be removed. They're not saying how it should be removed. And in fact, one of the biggest things I can teach you is that try to separate them as much as possible if you want to have novelty in your product. There's many ways to do the same thing, right? So if you say customer needs, what they want, functional requirement, how does the product accomplish what they want? So the product generates enough suction to remove accumulated dust particles from the carpet, as in a vacuum cleaner. There could be other techniques too. Maybe I can do electrostatic charging and remove dust that way, right? So that'll be a functional requirement of the product because I decided I'm going to do it in this fashion versus confusing with the customer. So what is the risk of conflating or confusing the two? Anybody think of a risk?
If we don't confuse the two, we can think of a cheaper method.
Cheaper method, better method, yeah, great idea. So yeah, cheaper method, more efficient method. But if we say, oh, the only way I know how to do this is this way, well, then you're stuck with a design and you'll never improve and you'll never have any novel designs, right? So you always say, the customer wants this, how can I achieve this? So customer wants something that can calculate for me. You can come up with a slide rule. If you say, customer wants something that uses mechanisms and all that to do calculations, you'll always end up with slide rules. But if you say customer wants something that can help them do arithmetic operations, then you can also come with a calculator, you can come with a computer and things like that. So good idea to delay thinking about functional requirements when you're encoding people's preferences. Okay, so next is house of quality. Have you done house of quality before?
Yes.
Okay, what is house of quality?
It's a basic it's a, diagram which will be in form of a roof. Like the diagram, one part will be roof, and in which the customer's requirements will be given, and it will be mapped with the this one functional requirements, and there mark like the severity will be given.
Yeah, we can. So yeah, so you have a general idea, right? So you're talking about something like this, right?
Yes.
Okay. So so yes, that's exactly it. So this is the general layout of a house of quality, which you must have seen before. In fact, one of my students found a very nice free template that I'll have the other instructor, Dr. Singh, share with you, which is like a very nice Excel template where you can enter things very well, and it makes a very nice house of quality. So on the left-hand side, you have customer needs statements, right? Just rows of customer needs statement. And then you have a column where you talk about importance of each customer need. I don't find it terribly useful at this stage because these are subjective measurements, right? So they say everything is important or nothing is important, or they might arbitrarily make one thing more important than others. In the middle, we have functional requirements. So each column is a functional requirement. I'll show you in a bit. And then we have mapping, right? So each column is a functional requirement, and then we have customer needs, and we put a dot or a cross, like, this functional requirement addresses this customer need. And then since functional requirements are columns, we look at correlations between them, and then we can mark correlations in the roof. And below the house, so to speak, we have targets for the functional requirements, right? So if it's let's say, some measurement, some dimension, you can say it should be between this and this, or the weight should be this and this, or the energy consumption should be between this and that. And on the right-hand side, you would have information on how competitors address customer needs. So you'll have, let's say, we want to do it like this, but looks like, let's check out how other people are addressing the same problem. Reverse engineering is a big deal, okay? A lot of manufacturers will go and buy products of their competitors, disassemble it, and see how they're doing it, that they have less failures, or they're able to do it cheaper, and so on and so forth. So there's nothing wrong with that. Okay, so
But is that the way of reverse engineering in a way ethical?
well, you have patent laws, right, to protect you. So I mean, if somebody buys the product, it belongs to you, right? So you can do whatever you want with it, so long as you don't make it unsafe and use it. But I think that once you buy it, it belongs to you, unless there's some specific laws. But I think that there's patent laws would protect you from somebody using the same design or same concept as yours, right? So like I said, customer needs to go here, importance go here, functional requirements and their correlation with customer needs go here, targets go here, information on competitors go here, and then your correlation between functional requirements go here. Okay, so pretty standard concept. I'm sure all of you have seen it. The thing that I would want to highlight is that the general concept remains the same, but different authors may draw it slightly differently. Okay, you might see a different column or something else. Don't get too confused by that, because the general setup is similar for everybody. Okay. So then we'll go over this commonly done vegetable peeler example that just allows us to understand the concepts, and then we can do this for more complex products then, right? So obviously practice at home or with your friends how I can come up with customer needs assessment. How can I fill out the house of quality for different products? Okay. So everybody's seen these things, right? You peel vegetable from it. Again, like I said, even though it's a seemingly simple product, and I still get surprised when I teach systems engineering. I haven't taught in a while, but I used to teach it pretty frequently. every single year I'll be surprised with somebody coming with a new technique to do something, or a new customer need, or new something, and so on and so forth. So even though it's a simple product, the process of needs assessment is similar for most products, right? If you go through the same process, you can work with more complex products. And then when we go over the chemical scrubber example later, we can talk about more details as they come for a more complex product. Okay, so as before, we'll be using house of quality to encode our customer needs. So customer needs expressed in natural language. The peeler should be able to remove a thin layer of skin from common vegetables. Okay, that's what the customer might say. It's natural language. There's nothing fancy about it, nothing scientific about it. But we'll see that when somebody says something as an engineer, as a designer, there's a lot of implicit things they mean from it, right? It's not just a matter of this. When you start parsing, it's like, do you mean this? Do you mean that? Is this correct or is that correct? Okay, so there should be clarity on the actual requirements from the peeler, right? So very quickly you'll start thinking, okay, well, there's a lot of vegetables. Some vegetables you don't expect to be able to peel with a handheld peeler. So you need to narrow the discourse a little bit. For example, what is the thickness of the skin to be removed from the vegetable? And it is a good idea not to think of an implementation at this stage. I was telling you before too, and this will become clear. When you're thinking customer needs, don't think functional requirements, because you will force yourself to reach a conclusion every single time, as opposed to having an open mind. Okay? So again, these things have come up in the class when I've taught this class before, that one should clarify if alternate methods of removing skin from the vegetable are allowed. For example, chemical bath. Somebody says, oh, why should we peel? We should drop it in this, I don't know, hydrochloric acid or some other chemical, and then it'll burn the skin off. Okay? Somebody can use a grater, right? A rough surface, you just rub it against a rough surface and the skin gets removed. So you can actually go back to the customer and have them clarify, is this allowed, right? Can we do this? Customer said, oh, no, I don't want chemicals near my food. Or they might say, grater is too complicated, I don't want graters. Okay? Then you remove those things, but actually that's implicit, and that's what I'm trying to say. When you say peel, in English, peel means removing a layer of skin. It does not mean grating, it does not mean other things. So you should never have gone there, but you did. So, so if the classical notion of peeling is implied, we can define that peeler with a cutting edge offset, that you have a cutting edge that is offset from another surface and you glide over it and you remove a skin. That's, even though we think we're imposing a functional requirement, that's what the customer wants, so it's fine, okay? And like I say here in the slides too, notice that this resembles a functional requirement and limits the types of designs possible. Okay, so a common convention, and that's something that you can take away from the slide, is that it should be written as the system or product needs to. Okay, that's what everybody writes it. If you have 10 lines, right, the peeler needs to, the peeler needs to, just to standardize things, okay? So we're still trying to stay close to the verbatim requirement, but we still try to standardize it. So safety, right? We could say restrictions on how sharp the cutting edge is, dimensions of the peeler. What are the different customer requirements? Let's do a poll here. Give me a few customer requirements for a peeler. Sharpness. And what gives me ergonomics? Okay. Durability. Flexibility.
It should be such that it should take the curvature of the vegetable.
Okay.
So cost.
Huh?
Cost
effective. Yes. Ambidextrous use, that sometimes comes up, but we talked about it last class, right? So, so that's the thing. Some designs are not for ambidextrous use. Anything else?
Most of the knives and peelers are ambidextrous.
right? Not necessarily. So once with just one edge and that's not flexible, it's not ambidextrous. So it's not for ambidextrous use. If you use the wrong hand, it won't work. And dust proof, rust proof, you said. Rust proof, yes, yes. So now you start thinking, even though you shouldn't, say, okay, well, maybe I should have stainless steel somewhere. Yeah, something like that. Or you could say dishwasher safe. You can talk about things like, so somebody told me in the class that the point that you have on it is to remove the stem from the apples, right? So some of us did not know that. So you can actually add requirements. You can say ergonomics. What does it mean to be ergonomic? It should be easy to grip, right? So are you saying easy to grip as in like, is it a soft grip? Some of them have rubber grips, or easy to grip as in like, not too thin. How would you feel if it was like 1 millimeter thin? How would you feel if it's like this big? So there's a lot of different things that are implied when you say ambidextrous, right? But we're not there yet. We're just writing down what it is that you want, right? So here I have, let's see if we missed anything. We have restrictions on how sharp the cutting edge is. So everybody wants a sharp cutting edge. But anybody does woodworking here? Okay, so if you have sharpened a chisel using the proper technique, then you'll realize how sharp metal can get. If you use a diamond file and then you use the proper techniques and use a leather strop, you can get really sharp. You don't want things sometimes that sharp, okay? Especially if you're keeping it at home. So, okay, so then we can say, okay, well, it should probably require a minimum amount of force before it starts working. Right? You don't want it to just brush something and start peeling it, or your hand starts bleeding. It should be not sharp, not too sharp, right? So dimensions, not too long. You don't want a peeler this big. You don't want a peeler really small. You want some reasonable size. Ergonomics was already talked about. Comfortable to use. Does not require excessive or too little force. Allows ambidextrous use. Long lasting, so it should be rust resistant. And safe for dishwasher use. Some people say that it doesn't mean the same thing as rust resistant, so we just have it there. Looks like we covered everything, right? Okay. So we have the needs. We want to now think about putting it in a house of quality. Okay, so now we have to think about functional requirements. Okay, so let's say the peeler needs to remove a layer of epidermis from common vegetables. This was proposed by students in my department. That's the language they use. A layer of epidermis. I don't know if epidermis is the right word, but that's what we have. Huh?
Top layer of skin.
Yeah. So then you have functional requirement, which is metal cutting edge protrudes about 1 millimeter. People say less than that. For most vegetables, you will still not get the entire skin. For some, you might get too much. So safe for handheld use. So we can say it requires minimum amount of pressure to work. So we can have a functional requirement that the pressure required is above a certain amount of force, right? And the distance between grip and blade. So this is another thing people say. Let's say you hold it here and the blade starts right here. So if your hand slips, you can cut yourself. So you say, okay, there's usually a 3/4 inch gap, like handle, gap, blade. It's not as simple as you think. Okay, then we say it should be greater than. It should be greater than 2 centimeters. It needs to be handheld. Means that not too small, not too big. Grip diameter should be comfortable, 0.8 to 1 inch. It needs to be ergonomic, so we can say, okay, use softer materials, have the curve or contour of your hand, and needs to allow ambidextrous use. Okay, needs to be dishwasher safe, needs to be long-lasting, rust resistant. So these have some implications on what the functional requirement could be or what material could be. Okay, so you know this, you've seen this. Left-hand side, the things that we already said, customer needs are listed there. Functional requirements are listed there. Some of these we've already talked about. And then here on the bottom we put the target functional requirements. Functional requirements should be something that you can quantitatively say or objectively say what it is, right? I want it to not, the peel should be 1 millimeter thick. Okay, so that's what it says. It requires minimum amount of pressure, 5 Newton force. Below that, it won't cut. Great. And so on and so forth. Now, we also have how competitors address it. So I just have one there, a carbide-coated stainless steel metal cutting edge. Okay, if you really want to get fancy, you could do something like that. So if you think that your peeler gets dull over time, you can make it carbide-coated. It increases the cost, but it also becomes a differentiating factor, so you can charge more. Okay. So these are targets. And there's a whole bunch of literature on how you do market research on competitors, what are the different techniques you use. We cannot, unfortunately, cover everything. And then correlations, like, some things. So this is a good thing to know, that if I want to do this, functional requirements, you're getting close to the design itself, right? So if you say, if I want to do this to the product, I want to do that to the product, do they conflict? For example, in a car, you can say, I want to make it safe. Use heavier metal gauge and on all that. I want to improve the fuel economy, make it lighter. So they conflict, right? So, I mean, I don't know if you know Triz, most engineering designs are at the edge of where things are starting to conflict. Okay, you improve one thing, you worsen the other. So it's good to know what the correlations are. If the distance between the grip and the blade increases to increase safety, of course the length of the peeler also increases, right? So there's a positive correlation between those. So in some product designs, you will see that some correlations are something that you need to pay attention to. You cannot do something to the product without affecting something else, right? All right, so that's pretty straightforward. And then you mark with X's what functional requirement addresses. Okay, do you say something? Okay, what functional requirement addresses which customer need, right? So you don't just write things and then go home. You can put a cross, or some people put a dot there, saying that the metal cutting edge offset addresses this need of the peeler removing a layer of skin from common vegetables. Comfortable grip dia, not too big, not too small, addresses this need. Peeler needs to be ergonomic. Okay. So every customer need must be addressed by at least one functional requirement. Correct. That has to be. You're saying the customer wanted it and we're not going to make it. Well, good luck selling that product. And every functional requirement must address at least one customer need. I mean, you should not put features just for the hell of it, right? Unless it's addressing some need that somebody somewhere has expressed. So it's pretty straightforward stuff. It's just like standardizing our knowledge, right? So you'll see this at work. You'll see this whenever you work and you explain something to other people, like, this is how I'm going to approach my design problem. And then you use these kinds of languages and people at least know what you're talking about because you're using standardized language. Right, so other products. Again, I would suggest that you do this. Go up with a house of quality for some everyday products, like an office stapler. Okay, these things take a long time. Once you start doing it, you say, oh man, this is some of the simplest things that you do every day, some of the most optimized things that you will find in real life. So office stapler, MP3 player, these things don't mean anything anymore. Media players, but they used to be big. And then any product of your choice. So take a complex product, see how somebody would make it. And I can assure you that so many times I look at everyday products and I just start thinking about it from a house of quality. I'm like, oh man, this is so much fun. And then it'll spur this interest in systems engineering, this whole idea of product realization, as we say, or system realization, as we say, conceptualizing, getting the needs all the way to making the product itself. Okay, so any questions so far? Huh?
Constraints between the functions. So how to identify the constraints between?
You mean correlations?
Yeah, correlation.
Okay, so obviously for for these kinds of things, for simpler things, I mean, of course, most of the time it's just like a little bit of thinking and analyzing lets you think that, are these two functional requirements independent of each other? Or if one increases, so usually we talk statistical correlation, at least I do. So if this increases, does that also increase? Okay. Or if this increases, does that decrease? So just to, hang on. Actually, I'm not very comfortable with this. There you go. So this column, if you project it, and that column, if you project it that way, they intersect there, right? So that's why I put a +1 there. If you don't know, you just put a 0, or you leave it open. So for example, the PL needs to support ambidexterity. That has nothing to do with comfortable grip dia, has nothing to do with metal cutting edge offset, right? So I'll put a 0 there. Required minimum amount of pressure and comfortable grip dia could have a correlation, right? So right now we might start with saying that it's a 0, okay? But anybody that has worked with things, you can see that if you're holding, let's say, a thin pencil, there's only so much force you can apply. But if you can grip it properly, you can apply a lot of force, right? So you will see that if the grip dia increases, right, then the force that you need to cut decreases. It becomes easier to cut, right? And you might actually hurt somebody if you're gripping it tight. So that's a great question. Yes, sometimes it's going to be independent. You can make that determination, negative or positive dependence. You can make that determination. Sometimes you'll have to think about it. Sometimes you have to collect data on something like that, right? So generally we see that increasing or decreasing this functional requirements affects this functional requirement. In fact, that goes into axiomatic design. Usually you want to keep them independent, because then you'll be stuck in this loop of.
So when you identify a correlation, is there an action to do, like how we verify the function, or is it on the optimization? If I optimize one, how do I optimize the other? What is the feedback that I'm getting when I do the correlation?
So right now you're just, we're before conceptual design even, okay? So we're just right now keeping it in our, there's techniques, of course. I mean, if you're interested, I can send you, there's research in this area, how to take into account correlations and what to do there. But for now, this just guides your thinking process, that don't think that you can just address this functional requirement without also affecting the other one. Later on, if you have a fully built mathematical model of something like this, then that correlation will automatically be a part of it, right? So when you start doing optimization, it will find the best trade-off of those from the correlation that you put in there. Okay, that's a great question. So yeah, so these things are not just to be there; they also guide you in the later stages of system development.